All right, so we're going to go over a mole conversion that involves two-step conversions. So on your worksheet, number 5 says, what is the mass of this many atoms of krypton? So the first thing we do is we look at what's given, 1.75 times 10 to the 18th atoms, and it's asking us to solve for the mass. So as you approach these problems, you're going to notice that, but then you're also going to refer back to these 3 tips, okay? And before we even look at the first 2, we're going to look at that last tip to figure out if we need 1 or 2 conversions. I've already told you we need 2, but how would you know if I didn't tell you? Well, when you see moles in the problem, it's only going to require 1 step. So as we read through this problem, we see that moles is not mentioned anywhere, okay? So that is just going to imply that we're going to need 2 conversions. So, all right, well, what do we do first? So the number of atoms was given in the problem. So we zone in on that first, and that's going to drive our first step. And so if you look at the second tip, it says when you see atoms or molecules, you're going to use Avogadro's number. So that's what will go in our first conversion, okay? So let's copy this down, 1.75 times 10 to the 18th atoms. We know we're going to need 2 conversions, so I would just go ahead and set up 2 conversions and then fill in what they are in just a moment. So I know I'm starting with atoms. I'm going to need Avogadro's number. Will Avogadro's number of atoms be in the numerator or the denominator? Denominator, because you want atoms to cancel with itself. So we need parentheses around it. Just 102 times 10 to the 23rd atoms. And that means the numerator of this conversion is going to be 1 mole. Remember, 1 mole is in every conversion. Then this next step is going to be, by default, not Avogadro's number, but the molar mass. So we had 1 mole in the numerator here, so 1 mole goes in the denominator. Molar mass goes up here. Krypton's molar mass is, oh no, y'all tell me. Okay, so that was the one I was thinking was 83. Okay, 83.80 grams. Okay. And just showing what cancels, just mark all that out. We solve for this, and for a 2-step conversion, you're always going to divide first. Okay, but you'll do 1 of each thing. You'll multiply and you'll divide, but we divide first. And so when we solve for this, we get 0.00024. Our final unit is grams, okay, and that's it, okay. So here's one more example. This one is going to give us 1.08 grams, which is the mass, and we're going to have to solve for the number of molecules. So do you see moles anywhere in this problem? No. Therefore, it is going to involve 2 conversions, not just 1. Okay, so the first conversion, let's go ahead and write down what's given, 1.08 grams. The first conversion is going to involve the unit of atoms, or excuse me, the unit of grams. So grams tells us that we're going to need to use what? Is it molar mass or is it Avogadro's number? Molar mass. So we're going to have to find the molar mass of calcium chloride. Okay, so we're going to add calcium and 2 chlorines. Remember, if you see a C and something that looks like this, this is a capital C, lowercase l, not a capital C and a capital I. So calcium is 40.08, and then chlorine is 35.45. Can somebody figure out what this molar mass is real quick? I think it's like 110 point something. 110.98. Is that it? Is that what you got? Okay, so we have grams. Where does that molar mass go? Numerator or denominator? The grams component. Denominator. So 110.98 grams goes in the denominator. 1 mole goes in the numerator. And then our second conversion is going to be Avogadro's number. Well, Avogadro's number is going to go in the numerator because we have 1 mole here. We have to have the same unit in the denominator as what we had in the numerator before. We don't have to put Avogadro's number in parentheses here, but it would not be marked, or it would not give you the wrong answer if you did that. So let's see what we get for our answer after we solve this in a calculator. Okay, 5.86 times 10 to the 21st. And this is going to be what unit? What's our final unit? Molecules. Good job. Okay, so this is one of each type of problem you would see that would be a two-step conversion.